Let's just note some important points. The vapor pressure and temperature are proportional. This does not imply that they are directly proportional. As the temperature of the liquid increases, the kinetic energy of its molecules increases. So there will be a higher rate of evaporation. I will see more particles of vapor here. The gas particles will start to increase in collision, causing higher vapor pressure. At the same temperature, if I have two liquids, like let's say liquid A and liquid B, they might be two different liquids, but if the temperature is the same, then the number of particles that will rise here and make vapor pressure will be the same. So the vapor pressure for both of them will be the same, although they are different liquids, but since they are at the same temperature, so they will have the same vapor pressure. This means for the same liquid, the only factor that's affecting the pressure of the liquid is the temperature. What are the minimum conditions for the liquid molecules to vaporize? The molecules first has to be on the surface. So the surface molecules will be able to vaporize easily, and they will have a higher kinetic energy than the energy that's keeping them in liquid state. So I have two forces. The force one is trying to pull the particles up and make them evaporate, and the other attraction forces from other particles are trying to keep the particles down and prevent them from evaporating. If the average kinetic energy is more than the energy keeping the molecules in the liquid state, then they are going to vaporize. So if I have water with vapor pressure of 17.5 millimeter Hg at 20 degrees centigrade, which of the following will increase the vapor pressure of water? Does transferring the water to a larger container changes the vapor pressure? No. We just said that the only factor that's affecting the vapor pressure is the temperature. So there is no effect here. Cooling water to 10 degrees centigrade, no, it does not increase the vapor pressure. Actually, it decreases it. Taking the container to the top of the mountain, no effect also on vapor pressure. Heating the water to 32 degrees, yes, because heating the water will make the particles try to break free, so they will change into gas particles, and then these gas particles will cause the collision with the container walls and causes higher vapor pressure. If the question asks what changes the vapor pressure, which means he did not determine increase or decrease, in this case, then the answer will be B and D, not only D. Now let's define the boiling point. What is the boiling point? This is the temperature at which the liquid vaporizes anywhere in the solution. Here the particles will be evaporating from anywhere. You can see the liquid here. Not only the particles on the surface will be evaporated, but liquid from anywhere in the solution can be evaporated and changed into gas. It's very important to note that when there is boiling point, the vapor pressure of the gas particles here will be equal to the surrounding pressure. This is a very important point. The bubbles of the vapor can form anywhere within the liquid. The molecules escape from the surface of the liquid to enter the gas phase. This already we know happens at room temperature. But Mr. You just said that it is from the surface and from anywhere within the liquid. Yes, from the surface that used to happen as a normal evaporation. Anywhere in the liquid, this happens only in the boiling. If you increase the altitude, the atmospheric pressure decreases and the boiling point. You just said that at boiling point, the vapor pressure is equal to the surrounding pressure. So what happens when you take this beaker and get it up a mountain? The vapor pressure will be the same, but the surrounding pressure is going to change. We know that the atmospheric pressure as you go up the mountain will start to decrease. So for the boiling to happen, the vapor pressure has to decrease also so that it will be equal to the surrounding pressure, so that the boiling will happen. And as we know the relationship between the boiling point and the vapor pressure, when the vapor pressure decreases, the boiling point also will decreases. So as a summary, when you go up a mountain, the atmospheric pressure is going to decrease. This causes the vapor pressure to decrease and the boiling point to decrease. The opposite is going to happen if you go to somewhere which is lower than the sea level. Here the atmospheric pressure is going to increase, and so the vapor pressure also will increase. Once the vapor pressure increases, the boiling point is going to increase. So if you have two containers, one with alcohol and the other with water, the alcohol boils at 78 degrees while the water boils at 100 degrees. If the atmospheric pressure is 750, what is the vapor pressure of each liquid? As we explained that if you are speaking about the same temperature, the vapor pressure will be the same. Although there is different boiling points, but the vapor pressure is not mentioned here to be equal to anything, so that's why we'll say it is similar in both of them, since the temperature is assumed to be the same for both containers. Now, there is something called normal boiling point. The boiling point is the temperature at which the liquid boils. The normal boiling point is the temperature at which the vapor pressure is equal to 1 atmospheric pressure or 760 millimeter Hg. So, in this case, also the vapor pressure is equal to the outside pressure, and the outside pressure is the normal atmospheric pressure, which is 760 millimeter Hg. That's equivalent to 1 atmospheric pressure. So, since at the boiling point, the vapor pressure is equal to surrounding pressure 760, so vapor pressure also will be 760. Draw the arrow lines.